In this video, we'll be talking about the fundamentals of writing JavaScript code. Now, most of these principles can actually be applied to any programming language, so if that sounds interesting to you, let's hop into it. So before you'll be able to follow along with this tutorial, you first need to download Node.js. So just go ahead to nodejs.org and download Node.js for your operating system. So once you've gone ahead and downloaded Node.js and installed it on your computer, go ahead and open a new VS Code window and create a new folder inside of it. I've named my folder Intro to JavaScript. And now we're going to go ahead and create our very first JavaScript file. I'm just going to name it script.js. Now, a couple things before we get started. The JavaScript that we're learning today is going to be run in a script, which means that it's going to follow the code from line 1 and run all the way through each line of code until it reaches the end. The first thing that I want to show you guys is how you can write a comment. Now, a comment is basically a line of code that does not get executed when you run your JavaScript. To do that, we just put 2 backslashes, and then we can type whatever we want. Another way that you can do this is by typing a backslash and a star, and then typing another star and backslash. Anything that you type in between this opening and closing will be considered a comment and not be run as JavaScript code. Now that you understand comments, let's talk about the 3 main primitive data types in JavaScript. They are numbers, strings, and Booleans. In other programming languages, there's usually a distinction between numbers that are whole numbers, i.e. integers, and non-whole numbers, like 1.4. In JavaScript, there is no distinction between whole numbers and non-whole numbers. So numbers can consist of the number 4, but also it can consist of the number 4.5. Now, strings are what you would think of as words, or anything that can fit between quotes. So for example, a name might be a string. However, numbers can also fit between quotes, and those would be considered strings instead of numbers in this case. Booleans can only be one of 2 values, true or false. Now that we've talked about the 3 primitive data types, let's create our first JavaScript variable. In order to do this, first we need a variable declaration, and I'm going to use the declaration let. Next comes the name of the variable, and you can make it whatever you want. Next, we use an equal sign to assign whatever we want my first variable to be. And after the equal sign is the value that we want it to be assigned to. So in this case, I have essentially set the variable, my first variable, equal to the number 4. In JavaScript, the equal sign is an assignment operator, which means whatever is on the left side of the equal sign is assigned to the value that's on the right side. If we wanted to create a variable and assign it a string value, we could use the variable declaration let again, a new variable name, the equal sign, and assign it a value within quotes. Whenever you finish a variable declaration, it's typical to end the line with a semicolon. But in newer versions of JavaScript, the semicolon is no longer necessary. The last variable that we're going to create is a Boolean, and we can assign it to the value true. So now that we've created our first variables, another tool that's very useful to see that our code is running is Console.log. Now, Console.log essentially prints out whatever value goes inside of these parentheses. So for instance, if I wanted to print out the value of my first variable, I would create the statement like this. Now, if you want to see this first variable printed out, you can hit Control- on either Mac or Windows, and it will open up this terminal at the bottom. Now, if you're running this terminal in VS Code, it should automatically put you in the folder that your JavaScript file is in. In order to verify this, you can type in ls in the terminal, hit enter, and you should see your script.js file get printed out in your terminal. Now, the only thing that you need to do in order to run your code is type node space and then the name of your JavaScript file. And if you hit enter, it should run your JavaScript code and print out the value of my first variable. The reason that I did this is because on line 20, we essentially asked our JavaScript code to print out the value of my first variable, which we have assigned to 4 on line 14. Likewise, if we wanted to print out my first string, we can replace this variable in our console log, save our file, run node script.js again, and it will now print out the value of my first string. Now in JavaScript, there are actually 2 ways that you can do variable declarations. The first keyword that we talked about was let. The second one is const. The main difference between let and const is that let will allow you to change the value of the variable, however const will not. So for example, this right here, I could reassign my first variable to be equal to 10 instead. And if we ran through our code and we printed out my first variable, we print out the value of 10. The reason is because on line 14, we originally assigned my first variable to 4, but reassigned it on line 16 to 10. Now, if I try to reassign another variable, which is a constant variable, and we'll assign it to 15, and I try to run my code again, we get an error which says you tried to make an assignment to a constant variable. JavaScript recognizes that another variable was originally declared as a constant, which means future code should not be able to change the value of that variable. Now that we've talked about the three primitive data types and variables, let's talk about how we can get variables to interact with each other. So if we go down here, let's create two new variables. We'll have a equal 5, and we'll let b equal to 7. Now what we can do is we can create another variable c and assign it to the value of a plus b. And if we console.log the value of c and run our code, then it prints out the value of a plus b, which is 5 plus 7. So in JavaScript, you can do regular arithmetic operations such as addition, subtraction, multiplication, and division between two variables that are both numbers. In addition, there's another operation that we can do. Let's create another variable d, and we'll set it equal to 10. We can actually reassign d to be equal to the old value of d plus another number. So in this case, we've essentially said we want d, the left side of the equal sign, to be equal to the old value of d plus 5. So if we console.log what d is, and we run our code, we see it prints out 15. And this as well, we can change it so that it uses multiplication, division, addition, or subtraction. So if I change this to a multiply instead, it should print out 50. To recap, this value of d that's on the right side of the equal sign is the original old value of d, and we are just reassigning this variable d to be the value of this quotient. So the four main arithmetic operators are addition, subtraction, multiplication, and division. If we want to do exponents, we could do a double star. So for example, we'll do variable e is going to equal 5, and if we wanted to do 5 to the second power, we could do let f equal 5 to the second power. And if we console.log f, then we get 5 to the second power, which is 25. Another powerful operator is the modulus operator, and it is denoted by the percent sign. So in this case, it takes the value that's on the left side of the percent sign, divides it by the number on the right side, and returns the remainder. So in this case, if we did 15 mod 2, that would leave remainder 1. So if we console.log g, then it returns remainder 1. Another way that we can show this is if we change this to 15 mod 4, 4 times 3 would be 12, which means there's a remainder 3. So if we run our code again, we get remainder 3. The last ones that I want to talk to you about are increment and decrement functions. So let's say we assign h equal to the value of 2. We can write h++ to essentially increase that h value by 1. So if we console.log h and we run our code, we'll see that it prints out 3. If we copy this line that we have on line 53 and add it 2 more times, we expect our code now to return 5, because we've essentially incremented h 3 times from its original value of 2. And if we wanted to decrement, we could simply use minus minus instead. So in this case, we have the value of 2, and we decrement it 3 times, so we expect our code to end up returning -1. So those are the main ways that we'll have variables interact with each other when they're all numbers. But now let's talk about the various ways that we can have strings interact with each other. So let's create a new variable, and this time let's assign it to the value of a string. And if we create another variable and assign it to another string, what do you think is going to happen if I add them together? So we add j and k together and we console.log L, and when we run our code, it prints out hello everyone. So when you use the addition sign, when you're adding two strings together, it appends the two strings. It essentially takes the first string and adds the second string onto the end of it. If we wanted to add a space between hello and everyone, we can simply add a space in between two quotes and then add k to the end of it. So now if we save our code and run it again, it'll say hello everyone with this space string that we've added in between our two variables. Now here's where it gets a little bit tricky. Let's go ahead and create a number variable, and let's actually add together a string and a number. So in this case, we'll create variable n, and we'll set it equal to j plus m. If you remember j, on line 68, we assigned it to the string hello, and on line 74, we assigned it to the number 5. what do you think it's going to print out now? So if we console.log n and we run our code, it actually turns m, which was originally a number, into a string so that it can add it onto the end of hello. So now the value of n is actually a string. There's actually a really useful built-in JavaScript function that we can use to verify this, and it's called Typeof. So if we console.log Typeof, and Typeof has parentheses, and if you put inside the parentheses the variable n and you run the code, it prints out string. Now the reason it prints out string is because the value of n is actually the primitive type string. If we were to change this n to an m instead, and we run our code, it's now going to print out a number because m, we assigned it to a number. And as you can imagine, if we were to create a new variable, let's create a Boolean and set it equal to true and print the type of variable O, then it's going to print out that it's a Boolean. So if any time you're running your JavaScript code and you're unsure what type your variable is, you can use this Typeof function to verify it and have it printed out into your terminal. So here's a really quick test. Let's create two more variables, and we'll assign p equal to 5, and we'll assign q equal to the string 5. And let's console.log p plus q. What do you think is going to get printed out? If you said 55, you were correct. And the reason is because q is a string, and the only way to add a string to a number is to turn that number into a string. So now let's talk a little bit about Booleans. Besides manually assigning a variable the value of true or false, we can use comparison operators to derive Boolean values. We'll assign the value of r equal to 5, and we'll assign the value of s equal to 5 as well. Now let's assign the value of t equal to if r is equal to s. Now this double equals is actually different than the single equals. Double equals actually means equivalency. So it's a comparison of what's on the left side and what's on the right side versus our single equals, which is the assignment operator, which assigns what's on the left side with what's on the right side. So if we look at this, we have r double equals s on the right side and t on the left side. That means that we're going to assign the value of t to whether r equals s or not. R equals 5 and s equals 5. So in this case, r does equal s, and we will return true. If we console.log t and run our code, then it returns the value of true, and that's because r does equal s. Now if we change the value of s to 6 and we run our code, then it returns false, because r does not equal s anymore. And there are many different types of comparison operators. We already talked about double equals, but there's also not equal to, greater than, less than, greater than or equal to, and less than or equal to. So if we went up here and we changed this to not equals, t is now the value of true, because 6 does not equal 5. Now remember how above we were talking about Typeof? Double equals actually does not compare the types of the variables. So in this case, if we change the value of s to the string of 5, and we said, are these equal to each other, JavaScript is actually going to say true, even though one of them is a string and the other one is a number. However, as soon as I change this to a triple equals, the triple equals not only compares the values of the variables, but also compares the type. So if I run my code now, it says false, because r is a number and s is a string. And just like how we have not equals to in double equals, we also have not equals to in triple equals. So if we run this now, we return true, because r is a number and s is a string. So Booleans come in extra handy when we talk about if statements. If statements are essentially conditional statements that we can write in code to say, I only want to run this chunk of code if this statement returns true. So if we create new variables, u and v, and we assign them equal to 5 and 6, what we can do is we can write an if statement that says, if u is equal to v, then I want you to console.log I am equal. So if we go ahead and we run this code, it doesn't print out anything. And the reason is because u does not equal v. If we go ahead and change v to the value of 5, and we run our code, it prints out I am equal. And we could do the same thing where if we say, oh, if u is greater than v, and this time we'll change the value of u to 8, then we should expect if we run our code, it should also print out I am equal. Now, if statements can also come with else statements. So for example, if I wanted my code to run a different chunk of code in the case where v is actually greater than u, I can create an else statement. And in all cases where v is greater than u, it will run this code. So in this case, let's change u so that it's 4, so it's less than v, and we should expect that our else statement prints out a console.log instead. And you can actually string along multiple else-if statements, where you provide additional conditions in case those conditions are met to print another chunk of code. So in this case, let's say if u is equal to 4, then we want to print I am 4. So if we go ahead and run our code, we print out I am 4 instead of I am in the else statement because this condition was met and we don't go on further in the if-else chain. That's an important distinction. Because if we just had two if statements, and we had another if statement which just said u equals 4. In this case, let's go and change v so that it's less than u, and let's change this print statement. And if we go ahead and run this code down here, it actually prints out both. And the reason is because just because this condition is met does not mean that it ignores the if statement right below it. However, as soon as I change this to an else if, the if statement chain is going to end as soon as one of the conditions is met. So in this case, u is greater than v, so it ignores the following else if statement and only prints out from the first if statement, even though the second else if statement is also true. So there are a lot of interesting things that you can do while playing around with all these different types of if statements. If statements can also be nested inside of each other. So let's say we go ahead and inside of here we put another if statement. So in this case, we will console.log u is greater if u is greater than v, but also we only print that u is equal to 4 if u is greater than v and u is equal to 4. So if we go ahead and we run this code, it's going to print out both. However, let's go ahead and change v so that v is equal to 5 so that it's greater than u. Because this statement is inside of this if statement, it's not going to print out anything, even though u is equal to 4. Because in order for this statement to be printed, it needed to first pass this statement. In if statements, there's also a list of logical operators that you can use. For example, if you're using two conditions inside of an if statement, you can use double ampersand for and, or there's double vertical line for or. So if we go back up to our example, we can take this condition and put it after a double ampersand in the first if statement. And now, in order to print u is greater, both of these individual conditions need to both be true. For ands, both conditions need to be true in order for the code inside the if statement to run. So if we go ahead and run this, we don't print anything because v is greater than u. V is set to 5 and u is still 4. Now if we change this to say, okay, now v needs to be greater than u and u has to be equal to 4, now both conditions evaluate to true, so it prints out the code that's inside the if statement. Now for using the OR logical operator, only one of these conditions needs to evaluate to true. So if we were to change this again so that u has to be greater than v, in this case it's not because u is 4 and v is 5, or u is equal to 4, either one of those conditions needs to be true in order to print u is greater. So if we run our code, it prints u is greater because u is equal to 4. As soon as we change this to another value, such as 5, both conditions evaluate to false, and that's why it doesn't print. However, if we change this, so now v has to be greater than u, so we'll go ahead and change u to be 3, and v is 5, so 5 is greater than 3, or u is equal to 4, which is not. Because this first condition evaluates to true, we now run the code that's inside the if statement. And that's why it prints out u is greater. Another fundamental component of JavaScript is loops. Now loops come in two main forms, for loops and while loops. Loops are used when you want to run the same code multiple times. For loops will run that code a specific number of times that you designate. So for example, if we wanted to write a for loop in JavaScript, we would write for let I equal 0, which is how we want it to start, I less than the number of times that we want the code to be run, and I++, meaning that each iteration through the for loop, we are going to increment I by 1. Now we talked about this variable declaration earlier, and this is essentially saying we are creating a new variable called I, and we're having it start at the value of 0. Next is the condition, and this is where we say we want to run this loop over and over until this condition is no longer true, where I is less than 10. And each iteration of the for loop, we do I++, which increments the value of I by 1. And the code that we want to run multiple times with the loop goes in between the squiggly brackets. So for example, if we wanted to print hello 10 times, this is the code that would do it. If we go ahead and run our code, we can see it prints hello 10 times, and the reason for that is because when I is 0, all the way up until when I is 9, we print the value of hello. As soon as the value of I is 10, it breaks out of the for loop and does not run the code that's inside. One way that we can prove this is instead of printing hello, let's actually just print the value of I. So if we go ahead and save this and run our code, we can see that at each iteration of the for loop, the value of I is 0, and the next iteration it's 1, and 2, 3, 4, 5, 6, 7, 8, 9, all the way until I equals 10, at which case I is no longer less than 10, so we break out of the for loop and no longer run this console.log code. So like I said, for loops are great for if you know exactly how many times you want your code to run. In this case, we designated that we wanted the code to run 10 times. But what if you're not sure when you want the code to end, and you just want the code to keep running until you reach a different criteria? That is where while loops come in. So to create a while loop, it's going to look very similar to an if statement. We're going to use the keyword while, and then parentheses where we're going to put a condition. In this case, let's keep it simple. Let's do where x is less than y. And then we have squiggly brackets to denote the code that we want to run while this condition is valid. So first we have to initialize the values of x and y. So we'll do let x equal 0, let y equal 10. Now inside of the while loop, we can write code that will change the values of x and y. So for example, we could do y equals y plus 1 and x equals x plus 3. So in this case, you can see that the value of x through each iteration of the while loop is going to be increasing by 3, whereas the value of y is only going to be increasing by 1. After a certain number of iterations through this while loop, eventually x is going to be greater than y, and this condition is no longer going to be true, in which case we will break out of this loop. So to demonstrate this, let's actually console.log the values of x and y inside of here. In this way, we'll be able to see how the values of x and y are changing through each iteration of the while loop. So if we run our code, we'll see that through the first iteration, x is 0 and y is 10. Through the next iteration, x is 3 and y is 11. And that makes sense because the original value of x was 0 and we just added 3 to it. And the original x of y was 10 and we added 1 to it. As we keep going, we eventually see that x keeps getting closer and closer to y until eventually it does overtake it. So the last iteration of the while loop is when x is 12 and y is 14. At that point in the while loop, y increases by 1, so y becomes 15, and x also becomes 15, in which case x is now equal to y and no longer less than y, and that is why we break out of the while loop, and the code on the inside no longer gets run. And just like if statements, while loops can also have and or statements inside of the condition as well. Some things to be wary of with while loops though is what happens if this condition is always true. Meaning, let's say that we set the value of x to 0, and we never change the value of x inside the while loop. If we ran this code, we would have what is called an infinite loop, because x is always going to be less than y. And then wherever you are running this code, it will just run that loop forever and ever until it crashes. So that's something to be very careful of when you are setting the conditions in a while loop. The last concept that I want to talk to you guys about with JavaScript is something called functions. Now imagine you wrote some code that did some really complex logic, a lot of loops, a lot of if statements, and then you had to reuse that logic somewhere else. Well, one thing that you could do is you could go and copy all of that code and paste it in the other location that you're going to use it. But the issue with that is what happens if you have to change the logic. Now you have to go and remember that you had that code in 2 locations and update it in both places. Now the great thing about functions is it creates a reusable chunk of code that you can now reference in multiple places. So let's create our first function. The way that you do that is you use the keyword function, and then you provide the name that you want to give the function. We'll just name it my first function. And then you provide opening and closing brackets, which inside of it you can provide parameters, but we'll talk about that later, and then squiggly brackets. The code that goes inside the squiggly brackets is going to be the code that gets run when you call this function. So to keep it simple, let's just do a console log that says hello. Now if we go ahead and run this code, we'll see that nothing actually gets printed out by this function. The reason is because this function definition actually acts as just a stamp. In order for us to actually run the code inside the function, we have to call the function after it's been declared. So this is a function definition, and this is a function call. Now if we run the code, we'll see that my first function, because it's called down here, actually runs the code that's inside of that function. Now when you're making a function call, you need to make sure that you have these opening and closing parentheses at the end of the name of the function. Otherwise, you'll just be referencing the variable that is the function definition. So just like when we were doing variable definitions before using let and const, this essentially is another variable, but we're using this keyword function to explain that this variable is actually being assigned to a function. Now, without having to copy the console.log code over and over, I can just call this function multiple times, and it will run the code inside of it as many times as I call the function. Now, like I mentioned before, functions can also have things called parameters. So in this case, to denote a parameter, you just provide a variable. It can be named whatever you want. We'll call it param, and it goes inside of the parentheses of the function definition. So in this case, I have this one parameter, and let's say that this parameter is actually the name. And let's say that this function is meant to say hello to whoever that parameter is. So in this case, we can say console.log hello, and we put the name. And now if we want to call this function, we can call my first function and instead put the name of the person that you want to say hello to inside of here. And if we run this code, that function will print out hello to whatever this parameter is. So whatever variable that you use to define your parameter, you can now use that variable inside of your function definition. So what's great about this is I can actually call this function again, but instead put a different name inside of here. And if I run the code, it will say hello to whoever's name I put in here as the parameter. Now this has a lot of really strong practical uses. For example, if I wanted to write a function that could convert Fahrenheit to Celsius, it would look something like this. Make sure that you have the function keyword to denote that you are creating a new function. We'll give a name to our function, and we'll name it to Celsius. And then we'll give it a parameter, and we'll just name that Fahrenheit. And this will be the parameter that we use inside of our function to do the conversion. Inside of our function, let's create a new variable, and we'll call it temperature. And we'll set that equal to the formula to convert Fahrenheit to Celsius. Now, if we want this function to return a value and not just print it out to the console, then we can use a keyword called return. And this will mean that when your function is called, it spits out this value. And then we can assign a variable to the result of the function call. Let me show you that really quick. So if we have this function return temperature, which is the value that we calculated here, this calculation uses this Fahrenheit, which is a parameter that's passed into the function. Now down here, we can create a variable, we'll call it result, and we can set that equal to our function call of to Celsius, and inside, let's give it Fahrenheit 90. So 90 degrees Fahrenheit, we want to know what that value is in Celsius. Now if we console.log result, we should be able to see what this function call returns. So if we run the code down here, we'll see that 90 degrees Fahrenheit is about 48.3 degrees Celsius. And if we want to compute this again, we could go ahead and just copy paste this code. Instead of copy pasting this formula up here, we can just copy paste this function call and instead change this to 80. And if we change this variable to a different variable name, because you can't have two variables that are the same name, and we run our code, we see that 90 degrees Fahrenheit is about 48.3 degrees Celsius, and 80 degrees Fahrenheit is 42.7 degrees Celsius. Now functions can take in as many parameters as you want, so let's actually go ahead and create another function, but this time we're going to have it take in two parameters. So a really simple example of this would be if we just wanted to add the two variables together. So we'll name this function addition, and we'll give it two variables, a and b. And all we want to return is the value of a plus b. And this can be used for both strings and numbers. So for example, if we want to create a new variable, we'll call it result1, and we'll set that equal to our function call of addition, and we just want to see what 1 plus 2 is. And we can console.log result1, which is the name of our variable. And if we run this, we'll see that the result of 3 is returned, which is what we expect. But we can also make another function call. We'll call this result2, and instead we'll pass in two strings. JavaScript is cool. And if we go ahead and console.log result2, we expect that addition will still be able to concatenate the two strings that we passed in as parameters. So to recap, in this function call, parameter A is the value of 1, and parameter B is the value of 2. As you can see, the order of the parameters up here corresponds to the order of the values we pass in down here. Now in the second function call, the first parameter A is assigned to this JavaScript space string. And the second parameter B is assigned to is space cool exclamation mark. And if you remember from before, if you try to add two strings together, then they actually just concatenate. You just put the first string and tack on the second string to the end of it. Now, as you can see, with all these tools in our tool belt, we should be able to create some very complex logic with functions that use if statements, conditions, loops, and then functions that call other functions. But hopefully after this video, you feel a lot more comfortable both reading and writing JavaScript code. If you've never written JavaScript before, I highly recommend that you take a look at some of the code that we wrote together in this tutorial and try it out for yourself. Now, all of these principles can be applied to any coding language that you want to learn. So even if learning JavaScript is not the end goal for you, this gives you a perfect framework and foundation to start writing code in other languages as well. Because in those other languages, they will have their own way of writing if statements, loops, and functions. So now you should have enough basic knowledge to go and start writing some JavaScript code on your own. If you have any questions, please let me know, and I'll see you in the next video.